Welcome back, everyone. Today is day 54, and we are unlocking one of the most powerful and elegant features in Python, Decorators. Imagine you have a standard wristwatch. It tells time perfectly. But what if you take it to a watchmaker and add a waterproof case, a glowing backlight, and a compass? You didn't replace the watch, you decorated it to do more. In Python, Decorators let us add extra behavior to our existing functions cleanly and easily. Let's dive in. Before we write our first decorator, we need to understand a golden rule in Python. Functions are first-class citizens. This means functions can be treated just like any other variable. You can assign a function to a variable, pass it into another function as an argument, and even return a function from another function. Let's see a quick example where we assign a function name to a new variable and call it. Keep this concept fresh in your mind. Let's take that concept one step further. Can we write a function that takes another function as an input? Yes, absolutely. Imagine writing a function called call_twice func that takes any function func and runs it 2 times. We pass our say_hello function into call_twice, and boom, it executes twice. This ability to pass functions around is the exact stepping stone we need for building decorators. Now, let's look at another foundational concept, inner functions, or nested functions. In Python, you can define a function inside another function. For example, inside an outer function called outer_func, we can define an inner_func and call it. Crucially, the inner function is hidden and protected inside the outer function. This encapsulation is the secret ingredient used inside custom decorators. What happens if an outer function returns the inner function itself without adding parentheses? Let's trace it out. When we call my_func equals outer_func, Python doesn't execute the inner code immediately. Instead, it hands back the inner function object and stores it in my_func. Then, when we call my_unc, later, the inner function finally runs. This pattern of returning functions is how decorators wrap functionality. Let's combine everything we've learned into a manual decorator. A decorator is simply a function that takes another function as an argument, wraps it inside an inner function with extra behavior, and returns that inner function. Let's write a simple decorator called my_decorator that prints a message before and after calling our target function. We'll pass say_we into it manually to see how it works step by step. Writing say_we equals my_decorator, say_we every single time can get tedious. Python gives us a cleaner, shorter way to do this using the @ symbol, often called syntactic sugar. By placing at my_decorator right above our function definition def say_we, Python automatically applies the wrapper behind the scenes. It's clean, readable, and saves us from repetitive code. Let's build a practical, real-world decorator that beginners will love, a timer decorator. Imagine you write a function that performs a slow task, like downloading data or running a loop. How long does it take? We can write a timer_decorator that records the start time using Python's time module, runs the function, records the end time, and prints the total duration. No need to modify the original function's code at all. Wait a minute, what happens if our decorated function requires arguments, like greet, name? If our inner wrapper function doesn't accept arguments, calling it will throw a type error. To fix this, we use *args and **quargs in our inner wrapper function. This magical syntax allows the wrapper to accept any number of positional or keyword arguments and pass them straight down to the original function. Let's write this out in practice. We'll create a decorator that logs every time a function with arguments is called. Our inner function will look like def wrapper *args *quargs. Inside, it prints function called with arguments. Runs func *args *quargs and returns the result. Now, any function, whether it takes 0 arguments or 5, can be decorated safely without breaking. Another fantastic beginner use case for decorators is logging. When building apps, you often want to know when a function starts, what arguments were passed, and when it finishes. Instead of scattering print statements inside every single function, you can create a single log_decorator and apply it to any function you want to monitor. It keeps your core business logic clean and separates your debugging tools. Did you know you can stack multiple decorators on top of a single function? For instance, you could apply both at timer_decorator and at log_decorator to the exact same function. Python applies them from the bottom up, meaning the decorator closest to the function runs first, followed by the one above it. Let's look at how stacking works and why it's such a powerful way to modularize code. As beginners start using decorators, there is one common trap you should know about: losing function metadata like the function's name and docstring. When a function is wrapped, Python sometimes thinks its name is now wrapper instead of your original function name. Don't worry, Python provides a built-in tool called functools.wraps to fix this instantly. Let's see how adding at functools.wraps func preserves our function's true identity. We've covered a lot of ground today. Let's do a quick lightning recap. First, functions are first-class objects in Python. Second, a decorator is a function that takes another function, wraps it with extra behavior, and returns it. Third, the @ symbol makes applying decorators clean and easy. Fourth, always remember *args and *quargs so your decorators can handle any function signature. Quick question for you: what does functools.wraps do? Exactly, it preserves our original function's name and docstring. That brings us to the end of day 54. Decorators might feel a little abstract at first, but the more you use them, the more natural they become. They are widely used in web frameworks like Flask and Django for routing and security checks. Practice writing your own simple timer or logging decorator today. Tomorrow, on day 55, we will explore Python generators and iterators to handle large datasets efficiently. Thank you for watching, keep practicing, and see you tomorrow.
Thank you for watching. Like if you learned something, share with your circle, and subscribe for more.